What would happen if a human fell into a black hole? Could anyone survive something like that? Today we're going to test it. Don't worry, we're not risking a real human body. Our lab intern, Tom, is about to experience it inside a simulation, which means he is about to discover what happens when a human encounters one of the most extreme objects in the entire universe. At first glance, a black hole looks like a perfectly dark sphere, but in reality, it's something much stranger. A black hole is a region of space where gravity becomes so strong that nothing can escape its pull. Not matter, not radiation, not even light. And as Tom moves closer, the gravitational pull rapidly increases. Every black hole has a boundary known as the event horizon. This is the point of no return. Once Tom crosses this invisible boundary, escaping the black hole becomes physically impossible, even if he traveled at the speed of light. Black holes form when extremely massive stars reach the end of their life cycles. When the nuclear fuel inside the star runs out, the outward pressure that once supported the star disappears. Gravity takes over. The star begins collapsing under its own mass. The core compresses further and further until it reaches an incredibly dense state called a singularity. According to Einstein's theory of general relativity, massive objects bend the fabric of space-time. The more mass an object has, the stronger this curvature becomes. Black holes represent the most extreme example of this effect in the universe. As Tom drifts closer to the black hole, something unusual begins to happen. From our perspective, his movement appears to slow down. This happens because the intense gravity of the black hole is stretching time itself. Near extremely strong gravitational fields, time flows differently. This phenomenon is called gravitational time dilation. In simple terms, time moves slower in stronger gravitational fields. For Tom, only a few seconds may pass. But for observers far away from the black hole, hours or even days could pass during the same moment. Gravity is literally distorting time itself. Einstein's theory of general relativity describes gravity not as a force, but as a curvature of space-time. Massive objects bend the geometry of the universe. The stronger the gravity, the deeper the curvature. Black holes create the steepest curvature known in physics. The radius of the event horizon can be calculated using the Schwarzschild radius equation. For example, a black hole with the mass of our Sun would have an event horizon with a radius of about 3 kilometers. But the greatest danger near a black hole comes from tidal forces. Gravity is not equally strong everywhere. Tom's feet feel a stronger gravitational pull than his head. This difference stretches his body along the direction of the gravitational field. As the difference increases, the stretching becomes more extreme. Scientists call this process spaghettification. Near smaller black holes, tidal forces increase extremely rapidly. The gravitational gradient becomes enormous. For example, the difference in gravitational acceleration between Tom's head and feet could exceed thousands of times Earth's gravity. Under such conditions, the human body would be torn apart long before reaching the event horizon. However, supermassive black holes behave differently. These objects can contain millions or even billions of times the mass of our Sun. Because of their enormous size, the gravitational gradient near their event horizons is much weaker. This creates a surprising possibility. For extremely massive black holes, the tidal forces at the event horizon can actually be relatively mild. In theory, a human could cross the event horizon of such a black hole without being immediately destroyed, at least for a short period of time. Once Tom crosses the event horizon, escape becomes impossible. Every possible direction now leads deeper into the black hole. Space itself is dragging him inward. Even light cannot escape a black hole, which means information cannot escape either. To the outside universe, Tom would appear frozen at the edge of the event horizon. But inside the black hole, he continues falling. At the center of a black hole lies the singularity. a point where density becomes infinite. At this point, our current understanding of physics breaks down. General relativity predicts the singularity, but quantum mechanics cannot yet fully explain it. Understanding singularities may eventually lead to a unified theory of physics. Eventually, everything inside the black hole must reach the singularity, a point where space and time collapse completely. So could a human survive falling into a black hole? Near a small black hole? Absolutely not. But near a supermassive one? Tom might survive long enough to cross the event horizon. Tom has returned from the simulation, slightly confused, but alive. Black holes may be terrifying, but they might also help us understand the deepest laws of the universe. Tom asked us to announce something. He will no longer participate in experiments involving black holes or anything that bends space and time. But if you have an idea for the next experiment, write it in the comments. Subscribe to the Observer Project. More simulations are coming.